Watch this, is going to be properties of solutions notes. That looks like an F. Notes. All right. So first thing I want you to go ahead and write down what a solution is. And if you can remember this from what we've talked about in class already, fantastic. If not, you can just copy what I put down. So a solution is a homogeneous mixture. A homogeneous mixture. So homogeneous means, and I misspelled homogeneous, but homogeneous means that it is the same throughout. The opposite of this would be the prefix hetero. And so homogeneous means the same throughout. Hetero means opposite or other. So this is a homogeneous mixture. A solution is a homogeneous mixture. An example would be salt water. Salt water. A bad example, a non-example, would be like a salad or a pizza. So so salt water is easily, it's easy to see that when you pour salt in water, which is the solute into the solvent, we'll talk about that again in a second, but when you pour the salt into the water, it is the same throughout. You may have to spin it or mix it a little bit, but it's going to be the same throughout. Pizza or salad, you can see individual pepperonis or onions or cheese or sauce or bread. Or in a salad, you would see croutons and cucumbers and salad dressing or whatever. So pizza and salad are good non-examples of homogeneous mixture. A really good example, kind of the one you'll see the most often, is going to be salt water. So we're going to talk about 2 parts in a solution. That's this next section. 2 parts in a solution. We've got the solvent and the solute. So we'll talk about the solvent. The solvent is typically it's going to be the large amount. And most of what we're talking about is going to be the liquid. It's going to be in liquid form, although it doesn't have to be. You've got different things that could be in gas or gaseous or solid form. But in this case, in most of the examples we're going to use in class, it's going to be a liquid. A solvent does the dissolving. Yeah. So a great example of this is H2O, and this is also known as universal solvent. This is to be contrasted with the solute. This is normally in smaller amounts. This is the part that gets dissolved. Example of this would be salt or sugar. And then if you want to draw this off to the side, we're going to draw a picture of Kool-Aid being poured into water. So we've got, let's go purple Kool-Aid. Being poured into a container that has water in it, and the H2O is the solvent. The Kool-Aid is the solute. and that would make a homogeneous mixture. Kool-Aid would make a homogeneous mixture or a solution. All right, I'm gonna draw a line. And let's go green. Let's talk about concentration. Concentration is the ratio of solute to solvent. So, for example, something that you may be familiar with is 1 cup of water to 2 grams of Kool-Aid. So that would be the ratio of solute to solvent. So we're going to draw something down here at the bottom. We're running out of room. We're going to try it. Let's try pink. And this may be odd at first, but I think it'll help. Goldilocks and the 3, not bears, but solutions. 1, because there's 3 solutions in this example, and Goldilocks, if you understand that, if you remember the story of Goldilocks, that should help you remember the, too little, too much, or just right. All right, so we've got, in these boxes, we've got, or you don't have to draw back boxes, unsaturated, saturated, and super saturated. All right, in the unsaturated section over here, we're going to write it can dissolve more solute, which meaning that the solution that's over here, it can hold more. So we've got the beaker with liquid in it. If we were to zoom in and kind of see this section, sorry, if we were to see this section, we would see not a ton of dissolved solute in the solvent. There wouldn't be a high concentration, low concentration over here. And then on the saturated, we're going to write it cannot dissolve anymore. Any more solute. Again, solute's the part that's less. Most of the time. In the case that we're talking about, it'll be the less. All right, I'll draw another beaker, about the same size, at least theoretically. And we've got the same amount of liquid. And then here, this little dot, we're going to look at. We've got as much as that liquid can hold. And the symbol we'll use to this, you may see, looks like a half-drawn arrow, one half drawn going one way, one half drawn going the other way. It's at equilibrium. That's what that means. It's at equilibrium. And the supersaturated is the solute. It's actually saturated, and then extra solute is gathering at the bottom. So we'll draw that same thing. It's not as if the liquid is holding more. It's actually the problem. The liquid is not holding more. That little piece, if we were to look at that, would still be, how many did I draw there? 7, 2, 3, 4, 5, 6, 7. So it's still holding the same amount, except for this, it's actually, the solute is actually gathering at the bottom. And you may have seen this if you've made Kool-Aid or made tea, and you put too much sugar or too much Kool-Aid in it, the solute is actually gathering at the bottom. The water cannot hold anymore. An example I gave in class is if I told you I can hold 10 backpacks with however much each backpack weighs, I can hold 10 backpacks. Well, if you give me 9, then that's unsaturated. That's going to be unsaturated over here on this side, on the left side. If you give me 10 backpacks, I'm holding exactly what I can hold. If you gave me 15 backpacks, there's 5 of those that I cannot hold, and so they're going to be on the ground in that example. So supersaturated solutions tend to happen where you've heated up the solution. The easiest way to do this is heat up the solution, make it very, very warm, very hot. So the molecules are moving very quickly. That means they can gather and hold on to a lot of the solute. And then when it cools, a lot of times it will drop all of the little pieces down to the bottom, and then you'll be left, at that point, you didn't see any stuff at the bottom, it's been agitated and the temperature has been raised to where it seems full, then you get to the end when it cools down and the solute drops to the bottom, then you know that liquid is at supersaturation. You cannot add any more.